Okay, it's all right. Let's consider these specific identities and some practice session based on these identities. Okay, these are some basic identities that I have here for you. Initially I'm taking sine theta is simply the ratio of p over h. Okay, cos theta is base over hypotenuse, tan theta is perpendicular over base. Just review all these identities quickly. Basically we are going to solve questions today. Then cos theta is b over h, tan is p over b, cosec is simply the reciprocal of sine, that is h over p, sec is simply h over b, and similarly cot is the reciprocal of tan, that is b over p. Even you can recall these identities. Cosec is 1 over sine. Okay, then sine is 1 over cosec, sec is 1 over cos, as well as cos is 1 over sec. Okay, let's recall them all quickly. Cos is 1 over sec. Then we have identities like cot is 1 over tan, tan is 1 over cot. If cosec is 1 over sine, that means sine into cosec is sine into cosec is 1. Is it okay for you? Okay, then let's consider the next. Then let's consider the next, that is sec into cos is 1, and similarly cot into tan is 1. And then we have sine square theta plus cos square theta, that is 1. 1 plus tan square theta is sec square theta. Similarly 1 plus cot square theta is cosec square theta. And then we have this entire table with us. This table is here, that is for trigonometric values. Sine at 0 degree is 0, sine at 30 degree is half, sine at 45 degree is 1 by root 2, sine at 60 degree is root 3 by 2, sine at 90 degree is 1, and similarly sine, after sine we have the values of cos. Cos at 0 is 1, cos at 30 is root 3 by 2, cos at 45 is 1 by root 2, cos at 60 is half, cos at 90 degree is 0. Tan at 0, tan is now sine over cos, that's why tan 0 will be 0 by 1, that's 0. Tan 30 degree is 1 by root 3, and similarly tan 45 degree will be 1, tan 60 is root 3, tan 90 is not defined. Similarly you can find cosec, as it is reciprocal of sine, sec will be reciprocal of cos, cot will be reciprocal of tan. Okay, try to go through all these identities very quickly, and then we have some very special questions to solve. First go through these identities very quickly. Rather I am presenting the identity part that I have explained earlier and today as well. Identity parts need to be well covered first. Okay, tan theta is sine over cos, cot is cos over sine, you know that, and all these identities you know that. I just want you all to quickly write down all these identities and recall all these identities. Other than these, there are some complementary angle identities as well, which are sine 90 minus theta is cos theta, cos 90 minus theta is sine theta, tan 90 minus theta is cot theta, and cot 90 minus theta is cot 90 minus theta is tan theta, cosec 90 minus theta is sec theta. Okay, I think you all are okay with all these identities. Okay, as you are okay with these identities, now let's consider the solution of these 10 most important questions. The first question is tan square a plus cot square a plus 2 is equal to sec square a times cosec square a. And let's consider these important questions. The second question is here, where we are going to use x plus y whole square. Third question is here, 4th, 5th, 6th. Total I have presented 10 questions first that we will discuss. Then we will cover other things. Okay, let's start with the first question. You all try to answer it. You all appear it along with me. Okay, let's start with the first question. You all solve along with me. That is the main thing. Okay, let's start solving the first one. I will write the question here. The question goes like this: tan square a plus cot square a plus 2 tan square a plus cot square a plus 2 yeah. Okay, let's solve this question very effectively. We will try to solve it. Okay, all right. Yeah, okay, fine now. Okay, all right. Okay, the question is here, tan square a plus cot square a plus 2 is equal to, we want this to be equal to cosec square a times sec square a. Okay. What we do in such a questions, first thing is we should have identities in our memory. This is the first thing to follow. If we don't remember identities, then we can't understand the approach. Okay, this is your LHS that you have. Is it clear for you all? I'm audible to all of you. Let me know that as well. Is it fine? Okay, all right. We are supposed to consider this LHS and prove it equal to RHS. This is my and our approach. Whenever we are supposed to prove such question, what you can do is, you can either take LHS and prove it equal to RHS. you can either take LHS and prove it equal to RHS. You can either take RHS and prove it equal to LHS. And you can either take both of them and prove it equal to some common value. These are three things that we do. Here we are considering LHS and we will prove it equal to RHS. This is the thing we will do here. Is it fine now? Is it fine now? Let me know that. Yeah, okay, we will take LHS and we will prove it equal to RHS. This is the approach we are going to apply here. This is the very simple approach we are following. Now, in LHS we have tan square A plus cot square A plus 2, and in RHS we have cosec and sec. Okay, that is why we will try to convert tan cot into cosec sec, and we remember the identity 1 plus tan square theta is how much? Do you remember that? Do you remember this? 1 plus tan square theta is how much? How much it is? Equal to which value it is? No, 1 plus tan square theta is sec square theta. 1 plus cot square theta is cosec square theta. That is why if we want to put something in the place of tan square A, we can write sec square A minus 1. That's we have written here. Similarly, in the place of cot square A, we can write cosec square theta minus 1, that we have written here, and plus 2 is also there. Okay, I am telling everything with all needed step, you don't worry, just focus here. Now what you can do here, you just take sec square A and cosec square A, and this minus become minus 2, plus 2 is already there, that's why they get cancelled. We now have sec square A plus cosec square A. Now the question become, prove sec square A plus cosec square A equal to sec square A times cosec square A. Even such a question may be asked in 2 marks, that prove sec square A plus cosec square A equal to sec square A times cosec square A. Let's prove it now. Okay, the next step is going to be, we are going to put these values in the place of sec theta. We will now write 1 over cos theta. In the place of cosec theta, we will now write 1 over sin theta, that you can see here. Sec A is 1 over cos, that's why sec square A is 1 over cos square A. Similarly, cosec square A is 1 over sin square A. I think you all are okay up to this step. Feel free to tell me if you have any doubt. Yeah. Now the next step is going to be the LCM step. Yeah. Are you clear up to this? Is it clear up to this? Okay then. Now the next step is LCM step. How do we take LCM? If we want to take LCM of these two values, we have to multiply the denominator, that we have done here. Now if we multiply these values, what we do is, sin square A get multiplied with 1, cos square A get multiplied with 1. And in this way we get sin square A plus cos square A over sin square A times cos square A. Now again one more identity is applicable here, that you must remember, sin square theta plus cos square theta is 1. This is the identity we need to remember. That is why in the beginning of the session I asked you all to remember these identities. I ask you to just go through these identities. I'm just quickly going through them once again. Sine is p over h, cos is b over h, tan is p over b, cosec is h over p, sec is h over b. Okay, cot is b over p, cosec is 1 over sine as well, sine is 1 over cosec as well, sec is 1 over cos, then cos is 1 over sec, tan is 1 over cot, cot is 1 over tan, cosec into sine is 1, sec into cos is 1, cot into tan is 1, sine square theta. These are most famous identities. Sine square theta plus cos square theta is 1. And from here only we can have two more identities that we can develop. And one is 1 minus sine square theta is cos square theta. Many a times we have to use this. From here only we can say that 1 minus cos square theta is sine square theta. 1 plus tan square theta is sec square theta. That also means sec square theta minus 1 is tan square theta. And that also means sec square theta minus tan square theta is 1. Whenever needed, we will apply these identities as well. Main identity is 1 plus cot square theta equal to cosec square theta. But sometime we have to use this as well. Cosec square theta minus cot square theta equal to 1. And also cosec square theta minus 1 equal to cot square theta. Okay, it is third, fourth times that I am repeating it for you. Then there is a table that you need to follow. Sine 0 is 0, cos 0 is also 1, sine 30 is half, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1. I have already told how to form this table. You today just try to remember these values. Similarly, cos 0 is 0, cos 30 is equal to sine 60, because we remember these identities as well. Sine 90 minus theta is cos theta. Similarly, cos 90 minus theta is sin theta. Tan 90 minus theta is cot theta. Cot 90 minus theta is tan theta. Cosec 90 minus theta is sec theta. Sec 90 minus theta is cosec theta. Here if you know sin 30, sin 30 is equal to cos 90 minus 30. Or cos 30 if you know, that is going to be equal to sin 90 minus 30. That means sin 60. In this way, we can relate values. Sin 0 is equal to cos 90. Okay, that you can see. You can just flip it. Okay, you remember cos 0 equal to 1, cos 30 equal to sin 60, that is root 3 by 2, cos 45 is 1 by root 2, cos 60 is half, and cos 90 is 0. Tan is actually ratio of sin and cos. Tan theta is sin theta over cos theta. That's why cot become cos over sine. Now tan 0 is 0 because this is the ratio of these two. Tan 30 is 1 by root 3. Tan 45 is 1 because same values having the ratio equal to 1. Tan 60 is root 3. Tan 90 is not defined. Okay, I have quickly helped with this revision again. Now come back to the question that we were solving. I'm just quickly going to help with the beginning. Tan square we have written sec square minus 1, cot square is written as cosec square minus 1, then minus 1 become minus 2, that got cancelled with 2. Now we have sec square a plus cosec square a, that we want to be that we can write as 1 over cos square a plus 1 over sin square a. Further we take LCM and it becomes sin square a plus cos square a over sin square a into cos square a. I think you all are okay up to this step. Here how to take LCM, we multiply the denominator first, then we cross multiply. I have explained it many times. Like if I have 2 over 3 and we want to add 1 over 2. What we will do here is we will take LCM of 3 and 2, and if you want LCM of 3 and 2, you rather multiply 3 and 2. The same thing we have done here. Now you will multiply in cross way. 2 times 2 is 4, you will write here. 3 times 1 is 3, you will write here. And your this LCM, this sum becomes 7 by 6. In this way you can add 2 by 3 and 1 by 2 to get 7 by 6. This is the approach that we follow for number. Same approach we will be following here for trigonometric addition. I think you must be getting it. And this sine square a plus cos square a is 1 that we have written here. Now we can distribute the because it is multiplication, we can distribute it. 1 over cos square a times 1 over sine square a. 1 over cos is sec, that's why it becomes sec square a, it becomes cosec square a, and that is actually the RHS we got. In this way we have proven the first question. Now come to the second question. These are identities we have used here. I have already indicated identities in the right side. You are also supposed to indicate them in the right side. Sec is 1 by cos, cosec square minus 1 is cot square, cosec is 1 by sine, sine square plus cos square is 1. These identities we have used in the question. Now let's consider the second question. Okay, what is the second question? First you need to learn that. I am writing the question here. The question is sin a plus cosec a whole square plus cos a plus sec a whole square, and we are supposed to prove it equal to 7 plus tan square a plus cot square a. This is the question. Okay, by observing the question, what we need to do is, I am telling that what we need to follow is, the first thing that we need to follow here is, we need to just know this formula, x plus y whole square. Do you know this? Tell me that first. Do you know this algebraic identity? Can you tell me this algebraic identity? X plus y whole square. It is x square plus y square plus twice xy. And this identity we are applying in, yeah, exactly, it is correct. We are applying it here as well as here. If we are applying this at this stage, it becomes x square, that means sine square a, y square, that means cosec square a, 2xy, that means 2 sine a cosec a. Similarly, we are applying this identity at this place as well. That becomes cos a is treated as x, sec a is treated as y, and we are applying this identity. That means x square, which means cos square a, y square, which means sec square a, 2xy, which means 2 cos a sec a. Now you need to remember these identities. Sin a times cosec a, what it is? Can you comment it? Can you tell me? Cos a into sec a is equal to which value? Do you remember this identity? Sin theta into cos theta, cos theta into sec theta. Sin theta into cos theta is equal to which value? Tell me please. Sin theta, yeah, it's 1 exactly, and cos theta into sec theta is also 1. Yeah, it is written here. Can you not see it? Right side I have presented it. Formula I am writing right side. Yeah, come down and zoom out if you find it bit large, because in app you can zoom in and zoom out, no problem in it. Is it okay now? Okay, I think okay, I am explaining it again if there is any issue. Sin a plus cosec a whole square, this is the question that we have here. We are supposed to prove, it is to prove sin a plus cosec a whole square plus cos a plus sec a whole square, and we want to prove this much. Okay, are you able to observe it carefully now? Are you able to see it now? Okay then. Okay, we have applied this identity algebraic formula, x square plus y square plus twice xy. Similarly here, cos square a plus sec square a plus 2 cos sec a. Now here we will write 1, Here as well we will write 1. This 2 plus 2 become 4. This sine square a time plus cos square a is 1. That means if we I have written 1 in the place of sine square a plus cos square a. I have written 2 here because 2 times 1 is 2. I have written 2 here because 2 times 1 is again 2. And finally, I am left with cosec square a plus sec square a. Now, what I have is, this is going to give you 2 plus 2, 4 plus 1, 5, that is written here. Now, in the place of cosec square a, we can write 1 plus cot square a. And the same thing is written here in the place of cosec square a, 1 plus cot square a. And similarly, in the place of sec square a, we can write 1 plus tan square a. The entire game is all about the identities. And you remember sec square a is 1 plus tan square a that we have written. Now, this one become 2 and this 5 becomes 7. That's why 7 is here. Tan square is here, cot square is here, and this is actually the RHS that we want. You can see here in the RHS side, and hence we can say that it is proved. Is it clear to all of you? Let me know that first. Is it clear to you? Okay. Okay. If you are okay with this solution, I can now proceed with the third question. Third question is here. The question goes like this. I'm writing the question first. Actually, I have in my other classes I have helped student to solve these, and I have directly taken the solution part so that I can explain these things by saving some time. The question is here. I'm writing. Question is here. Question goes like this. LHS, in your LHS you have cos A minus 2 cos cube A over 2 sin cube A minus sin A, and you need to prove it equal to cot A. This is what you need to prove. Can you see the question now? And if you want to solve this question, these are the steps we need to follow. First, we will consider LHS. This is our first step. Considering LHS means you can write the LHS once again, and then you can approach like this. You will take cos A common. Cos A is here as well as here. Cos cube means cos A is written 3 times. Cos cube means cos A is 3 times, and 2 means 2 is also multiplied. If we are taking cos A common, we will be left with 2 cos square A, that you can see. Here as well we can take sin A common. We will be we are left with 2 sin square A minus 1. Then this cos A over sin A has a formula that we know. Can you now tell me what do you know? What do you know about this cos A over sin A? Is it cot A that you know? And cos A over sin A, cot A. That's why we have written cot A in the place of cos A over sin A. Now you do a thing. Either you put cos square theta equal to 1 minus sin square theta, or you put sin square theta equal to 1 minus cos, but you put only at one place. Here I have substituted in numerator side cos square A equal to 1 minus sin square A. Then we have simply simplified it. 1 minus, how can we simplify? We will allow this negative 2 to distribute further. 1 minus 2 times 1 is minus 2. Minus 2 times minus sin square A is plus 2 sin square A, that we did here. Then we have the next step to follow, that is cot A is here. 1 minus 2 is going to be minus 1, that I have written here, and 2 sin square A. And in this way we have cot A and 2 sine square a minus 1 in numerator as well as in denominator, that can be cancelled, and finally we have cot a in our answer, which is actually RHS as well, and hence we can say that it is proved. Are you okay with this? Got all these steps that we followed here? Please ensure first, then only we can proceed with next question. I have considered 10 most important questions in today's session that we will try to answer today, try to cover today. Initial 5 are there with solution, and from 5th onward, which are bit difficult, we will analyze everything. Okay, let's consider the 4th question. In the 4th question, I will just write the question here. You just observe the question first. The question is sin power 4 theta minus cos power 4 theta, and you need to answer it equal to this much, 1 minus 2 cos square theta. This is your question. Okay, before we start with this question, I just want you to know it. If you have 2 raised to the power 2 and you are taking power 2 again, it is actually 2 raised to the power 2 times 2. That is actually 2 raised to the power 4, because we have this identity. This is exponent rules that you must have studied in 7th, 8th or maybe 6th class. X to the power m times x to the power m to the power n, then it becomes x to the power m times n. The same thing we are applying here. Okay, I think you are okay up to this. Are you? Okay. Okay, if you are okay up to this, we can start with the 5th question that is here in front of you. Just presenting the question. Okay, this is the question. It is your LHS given. I will just indicate everything, you don't worry. You are supposed to prove it equal to 2 sin theta cos theta over sin theta plus cos theta. This is your question. I am just indicating here itself. The question is 1 plus tan theta over sec theta minus sec theta over 1 plus tan theta equal to how much? Equal to this much, 2 sin theta cos theta over sin theta plus cos theta. Okay, let's solve this very carefully. 2 sin theta cos theta over sin theta plus cos theta. Okay, by observing RHS as well, we decide our approach. Don't think that RHS doesn't play any role. From RHS itself, we decide that what approach we need to follow. As here we get everything in sine form, that's why we will convert tan and sec into sine and cos. And these are some formulas that we will be using. We will use tan theta equal to sine over cos, sec equal to 1 over cos. Okay, let's apply all these conversions. This is LHS that we have considered. This is the question. Prove that 1 plus tan over sec minus sec over 1 plus tan equal to how much? 2 sin theta cos theta over sin theta plus cos theta. This is your question. What we have done is we have considered LHS. Now, in the place of tan, we are writing sine over cos. In the place of cot, we are going to write cot is not here. Okay, all right. In the place of sec, we are going to write 1 over cos. Tell me if you find any difficulty up to this. Okay then. Now the next step is, if nothing is there in denominator, 1 is always there. Okay, that's why you can take 1 here. 1 is always there. That's why you can take 1 here. Okay, all right. Okay, all right. Now what you can do is, you can just write 1 here, just write 1 here, and now after doing all these, you need to take LCM. That is the step we need to follow. Observe it carefully first. Now how to take LCM? The LCM of 1 and cos is cos, and if you are taking these two as product in your LCM, then you need to do a very important thing here, and that thing is, you need to cross multiply. Cos got multiplied with 1, you got cos theta. 1 got multiplied with sine, you got sine theta. After this, what happens is, cos theta plus sine theta over cos theta is this entire portion, and 1 over cos is already here. In 1 and cos has LCM cos, and now you have to cross multiply. Cos times 1 is cos, 1 times sine is sine. Now this scenario is here, 3 over 2 over 4 over 5, like this, x over y over a over b comes. Then what you can do is, x over y times b over a. We just reciprocate this value if we multiply here. Okay, this is the approach we do. This is the approach we follow. Same thing we are doing here. This got, this is like x over y, and this portion is like a over b. Similarly here, x over y and a over b. And if you are multiplying, you will just reverse it as cos over 1. Similarly, reverse it as this. You cancelled cos, 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 cos. Finally, you got cos plus sine over 1 and 1 over cos plus sine. From this step onward, you are again supposed to take LCM. Again, you have 1 here, and that's why LCM is the product of these two, which is sine plus cos, or cos plus sine, both convey the same sense. Here now you have to multiply this, cross multiply, cos plus sine square, and 1 square is always 1. Again you have to apply x plus y whole square here. That I think you are very much okay now. And finally we have just written this, and this value is nothing but 1, and this 1 got cancelled with this 1. You only left with 2 sin theta cos theta over sin theta plus cos theta, and that is what we want to prove. That is what we got. That is equal to RHS actually. And in this way we have proved what we are supposed to prove today. Let me know if you have any doubt anywhere up to this. Are you okay up to this? Yeah, this is the most important question because it has even utilized many of the concepts, utilized many of the formulas. Now let's quickly review all these 5 questions that we have solved now. This was the 5th question. Before that we solved this 4th one. Then before this we solved this 3rd one. And I have already indicated the 10 most important questions that we are supposed to cover in today's session. Not only these 10, we will cover even more if possible, but these 10 we need to consider first. And here we have this entire, these questions are here. I will just consider the sixth question now. If you have any doubt anywhere in these 5 questions, first tell me. I will just repeat for you, no problem at all. I can repeat these. Any one of you, you can comment if you have any doubt anywhere. You can tell if you have any doubt anywhere. If not, then we can consider the sixth question and onward. Okay. Are you fine with this? Should we take the next question? Yeah, I'm scrolling it so that you can ask the doubt if you have any. Any one of you, if you face any difficulty, you can just let me know. I will just explain the step that you want me to explain again. Okay. If you are okay with all these, then we have opportunity to start with the sixth one. Should we take the sixth one now? Okay, here we have now 6th, 7th, 8th. Let's take them. Let's consider these then. Okay, fine. Sixth question I'm taking now. Okay, all right. What is the sixth question? You all first try to answer and then observe the solution as well. I'm writing the question here first. Now I don't have solution, I have to solve it for you here. That will take bit time, but that's actually the questions are important, that's why we will solve together here. Here as well we are supposed to prove. What we are supposed to prove? We are supposed to prove this value, that is 1 minus cos theta plus sin theta over 1 plus cos theta plus sin theta whole square equal to 1 minus cos theta over 1 plus cos theta. This is the question. Okay, let's consider its solution. Whenever we solve such a problems of trigonometry, we are using identities and we generally consider LHS or RHS, any of term we can take, any of the portion we can start with, but we generally start with that part which is in complex form, because simplifying the complex is easy. That's why we will take LHS here. This is the sixth question. We are considering LHS, okay? Yeah, this is the new question. Yeah, we are considering LHS. That's why write this LHS again, 1 minus cos. Yeah, you can do all these steps in your exam as well. If you are considering LHS, you can indicate LHS again in your like this. Now as you can see, it is somehow what you want in RHS. We want cos in RHS. Okay. Now question arises, what to consider, what to take, which value should we consider here, because it is a square. It is a square, that means it is the formula we are supposed to use here. And the question arises how to use it, because there are 3 terms. If there are 3 terms, you can deal it in this way. 1 plus, you can consider sin theta minus cos theta as y and 1 as x, and it is going to be the first identity, x plus y whole square. Similarly, in denominator you can write it as 1 plus sin theta plus cos theta. Don't confuse with this. Actually, sin theta plus cos theta or cos theta plus sin theta, it is commutative law we call. Both are same things, no problem in it. Okay. Now how to implement this formula here? This is the question, how to implement. Let's implement it. How can we implement it? We can apply it. X square, that is 1 square, plus y square, that means sin theta minus cos theta whole square, plus 2xy. 2 x is 1 and y is sin theta minus cos theta. Let's write all these things. Similarly, you apply or expand it here as well. If you expand it here, how will you expand? X square plus y square. X square is 1 square plus y square plus 2xy. Here you have 2 sin theta plus cos theta. In this way we have expanded. Observe it carefully and tell me if you have any doubt. Okay, I think you must be okay with this. Now again we need to apply expansion, same expansion for this and this. Let's apply that. 1 plus x square plus y square and minus 2xy, and this is here 2 sin theta minus cos theta. Similarly, in denominator we have 1 plus sin square theta plus cos square theta plus 2 sin theta cos theta and plus 2 times sin theta plus cos theta. Okay, let's check whether we are getting our answer with this approach or not. If we, okay, this much is going to be 1, as we know that this much is going to be 1. Okay, now 1 plus 1 become 2 and minus 2 sin theta cos theta we got, and here we have this much. What we want to get? We want to get this much, 1 minus cos over 1 plus cos. We are supposed to obtain 1 minus cos over 1 plus cos by solving all these. Yeah, you all attempt now, try to complete it, whether you are able to get answer with this one or not. Take 2 minutes to answer it. The question is so important, rather taking a logical approach as well. Now after this, what to follow, what to do? To get this value. Okay, how much we obtained? We have just obtained 2 minus 2 sin theta cos theta, and this value is also here. It will be a bit difficult to get answers. You just take 2 minutes to apply your logical approach. And you can even think of some other approach if possible. You can think of some other approach as well. Okay, here I have taken sine and cos. We can even take 1 minus cos as x, like that we can do. You just think of some other possibility if possible. We can even take 1 plus sine as, yeah, we can think of some other possibilities. Because it is taking bit, yeah. Okay. One minus cos. There are some formulas that can be used, but for your standard I will not suggest to use that. Actually there are some formulas like 1 minus cos theta and 1 plus cos theta. If we substitute these formulas, it will be very easy to answer. Like this is 2 sin square theta divided by 2. It is 2 cos square theta divided by 2. But I will not suggest to use that. Sin theta is also 2 sin theta by 2 cos theta by 2. And by putting this, we will be able to get answers easily. But we are not supposed to use them for your standard, your level. That's why we will approach only those steps that we are supposed to implement in our level of standard. Okay, let me think as well, even I need to think a bit. Okay, alright, if we further try to solve with this approach, it will be, I think it will be a bit difficult, but let's try a few more steps. Maybe we get some idea. Okay. Okay, it's taking, yeah, it is going to be a bit difficult. I'm not saying that question can't be solved with this, but this is going to take, I have to change the approach, because from here, yeah, it will be a bit difficult to answer. Okay, let's consider another approach. Approach is simple. Okay, even I have to think bit for this one, no problem. I can now consider other approach here. What we need to do here is, now what we have done, we have taken this 1 minus, we have taken sine minus cos. Rather than that, let's take these values. What values? I'm telling that. Let's take these values. We are considering LHS, that's fine. There is no problem up to this. Now, rather than taking sine minus cos, now we have to change the approach. That is what, from this error itself you need to learn. Okay, because this approach is not going to give you what you are supposed to get. That is why we have to change the approach. What is the change in this approach? We are not going to take sine minus cos now. Rather, we are going to use this thing. Here I am changing the approach. I am erasing so that you can see the approach, change in approach as well. Many times this happens. Many times this happens if there is lack of practice. Okay, even if we get a question first time, then we can have such error and trial approach that we use. Now, as we are not getting what we are supposed to get by taking sine plus cos and sine minus cos as x and y, now we will take 1 minus cos as our x and sine as our y. This we are doing with LHS, yeah, your numerator as well as in denominator. We will do the approach, same approach. What we will do is, see, now you all try to answer. Just one change in approach may lead to get the answer easily. 1 plus cos theta plus sin theta. Okay. Actually, taking cos theta plus sin theta and cos theta minus sin theta is making the question more tedious, and what we are getting is not equal to our RHS. That's why we have to change the approach that we are changing this time. The condition is again same. We have to apply same thing, x plus y whole square we have to apply. Let's apply x plus y whole square. You all try to answer it now. You all try to answer it now. And by this error approach, this is also an approach we can say. This is not the mistake. This is an approach, we say error and trial approach. But generally this approach is not suggested when you are appearing board exams, because that will that will waste your time rather. But when you are answering it now, you can use this approach. Okay, because we learned from these approaches. Okay, what we do now is we can now apply this formula, x square plus y square. Okay, you can now apply this approach, x square plus y square plus 2, this is your x, this is your y. Okay, similarly you open your denominator. Now it's all up to you. You all try to answer it for now. Don't see the solution, now try to answer it. We have to change the approach. You can indicate it in your copy as well, that we have to not apply this approach, otherwise we will not be able to get what we are supposed to get. That is not the incorrect, there is no mistake here, but we will not be able to get the RHS. That's why we have to change the approach. That we did here. Okay, now what is there in RHS? You can just answer it as well. It is 1 plus cos theta whole square, that is x square. This is actually x, I am decreasing its size. This is actually x and this is y that I am considering, plus y square. Similarly here, 2, this is x, this is y. Are you okay up to this? Are you okay with this? Are you okay with this? Please tell, please comment and let me know that. Now again we will apply the same approach, x square plus y square minus 2xy, that is cos theta. plus sine square theta is there, plus 2 times 1 minus cos theta sin theta is there. Similarly, in your denominator part, x square plus y square plus 2xy is here, then this sine square theta is here, then 2 times 1 plus cos theta is here, times sin theta is here. Okay, I'm following the step here. Cos square theta plus sin square theta become 1. This becomes 1, and this 1 and this 1 is 2. 2 minus 2 cos theta plus 2 times 1 minus cos theta into sin theta we got. Here as well, this cos square theta and this sin square theta will be 1. This 1 and this 1 become 2. 2 plus 2 cos theta, and here we have 2 times 1 plus cos theta times sin theta. Don't worry, the solution is so easy now. By changing the approach, we will be able to get what we are supposed to get. Now here, from here, you can take 2 as your common. You will get 1 minus cos theta. Here you have 2 times 1 minus cos theta. Here you have sin theta. Again, come to the denominator part. You have 2 as your common, 1 plus cos theta. 2 times 1 plus cos theta times sin theta. Now it's so easy to consider common. Again, what you can take common here is, you can now consider this value common. This entire value is here as well as here, that you can take common. 2 times 1 minus cos theta. If you take it common, that means you have taken entire value common. That means 1 is left now. If you taken this common, sin theta is left here. This is numerator. Now in denominator again, this much can be taken as common. That means 2 times 1 plus cos theta is common. You will get 1 here and sin theta here. Now it's so easy, very easy. You are supposed to cancel these two because everything is multiplication. These, you got what you are supposed to answer. This is your RHS, and hence it is proved. Question is very, very, very interesting. Even I committed a bit mistake here that lead to the step from where we can't get RHS. That is why I have to change the step. That is why I have to change the approach. Now I am explaining what I did earlier and what we are supposed to do actually. Okay, what I have initiated is, I have taken sine minus cos as y, 1 as x, sine plus cos as y and 1 as x. But here you need to take this as your x and this as your y and then expand. Okay, then only you will be able to answer it. And that's what we have done. We have taken LHS, considered this itself as our x, this as our y, that I have indicated here, x and y here as well. Now you need to open it using this formula, x plus y whole square equal to, yeah, you can see it, x square plus y square plus 2xy, that you can see. X square, see carefully, x square, that means 1 minus cos theta whole square, plus y square plus 2x is here, y is here. Again in denominator, x whole square, y whole square, twice x, and this is y. Further you need to apply this formula, x minus y whole square and x plus y whole square again, that you remember now. It is x square plus y square minus 2xy, and it is x square plus y square plus 2xy. Again and again, if you will be using this, you will be able to remember all these. That is the approach we follow, and as much practice you will be considering, you will be doing, you will be able to get the exact approach. X square y square minus 2xy, then sine square is there, this is there. Similarly, we have opened RHS, and finally we have just written cos square plus sine square equal to 1 in both numerator and denominator. 1 plus 1 become 2, and finally we have taken 2 minus 2 cos theta as our common. Similarly, 2 times 1 plus cos theta is common from denominator as well. We can now cancel 1 plus sine 2, 2, and we got what we are supposed to get actually. Okay. You all please let me know if you have any doubt in this. Is it clear to all of you? Is it clear to you? Please let me know that, so that we can proceed further. Are you okay with this solution? Okay, if you are all are okay, then we can start with the 7th question. There are 10 questions here. 7th one is 1 minus cos square theta plus sine square theta over 1 plus cos square theta minus sine square theta, and we want tan square theta here. It is what we want to prove. Let's try to answer this. First step is we will consider LHS. I am writing this step here, and I am considering this step. I am considering this LHS. Okay, consider LHS. Now, what you can do is, if you remember this identity, it's going to be very helpful for this. From here only we can get 1 minus cos square theta, which is actually sine square theta, and in the place of this we can write that. From here only we get 1 minus sine square theta, that is actually cos square theta, and in the place of 1 minus sine square, you can rather arrange it first. 1 minus cos square theta plus sine square theta. You can arrange your denominator 1 minus sine square theta plus cos square theta. Now here you can write sine square theta. You are left with sine square, one more sine square. Similarly, here you can write cos square theta, and you have one more cos square. Finally, you can add sine square with sine square. If two things are added, that means 2 times sine square. Similarly, if you are adding cos square with cos square, that is 2 times cos square. We could cancel these 2 and we got sine over cos, and sine over cos is nothing but tan theta. I will suggest you to approach this. It is even easier than the 6th one. In the 6th one, a bit approach is needed. If we directly take 1 minus cos and 1 plus cos in the previous question is one of the important, as you need to remember or you need to follow the approach. If you just miss the approach, you can just error and try. That's a error and trial approach here. Then you have to take 1 minus cos and 1 plus cos as x and sine as y then. Okay, let's consider the new question, the 8th question, if you are okay with this 7th. 7th is rather easier than the 6th and other as well. Let's consider the 8th question now, if you are okay up to this. These identity based questions are going to help you remember all identities. That is actually the utility, and that in this way only we can remember the identities. Now the 8th question that we are supposed to consider, supposed to prove, is also the most important question. They all can be asked in 3 or 4 marks. The 8th one is tan A plus sec A minus 1 over, it is also the most famous question, one can't solve this question if he has not solved it earlier. Such a question must be solved 2-3 times before you appear the exam. You can't just put the logic just suddenly. You have to work for such a question. Okay, let's consider its solution. In order to answer this question, what you need to do is, see, you have tan A, you have sec A, and in the place of 1, do you remember 1 plus tan square theta is sec square theta, and that is why sec square A minus tan square A is 1. And I will suggest you to write same thing in the place of 1. This is one of the tedious approach, I should say, but not tedious approach, but tedious to think, not easy to think. Okay, now after putting 1 equal to this, now we will write x square minus y square. We will use it here. And do you know this? It is simply x plus y. Do you know this? I think you know this, and I am now yeah, let's apply it. How to apply? Let's see. Sec A plus tan A, okay, sec A plus tan A times sec A minus tan A. This is the identity x plus y, x minus y. That is what we have done. Here we have tan A minus sec A and plus 1. Okay. Now I will suggest, okay, first you observe it, the step is quite interesting. In the place of 1 we have written sec square A minus tan square A. In the place of sec square 1 we have written sec square A minus tan square A. Then we have applied x square minus y square, x plus y times x minus y. Now we will follow this step. Now we will take some common if we can. And this entire value, see, this entire value and this entire value is seem to be same in both terms. That's why we can take this tan A plus sec A common. We are left with 1, and minus is here. That's why minus will be distributed with this sec A, and this minus will be distributed with this minus tan A, that becomes plus tan A. And what you are here with denominator, it is 1 minus sec A plus tan A. The same thing is there in denominator. That's why you can cancel out them, and you are left with tan A plus sec A. Do you want this RHS? Let's see.